Hey guys, so this video is on factoring x squared plus bx plus c. So this was our second day of factoring after our lesson on factoring out a GCF, where we're looking for the greatest common factor between all the terms in a problem that we're looking at. So remembering to look for the number parts for our GCF and the variable parts that each term might have in common. And this type of factoring only works when we have a setup like this, where I have an x squared term, an x term, and my constant, so my number part. So to start off with, we're going to look at the area model that we've been talking about. And notice that I already have it filled in. So I have the dimensions and the area on the inside of our area model. So you can see our dimensions x plus 4 on this side, and x minus 6 on the bottom. And when we multiplied those, so kind of going back to when we were multiplying polynomials, we know that x times x is how we got the x squared term. 4x times x is how we got 4x. And 6 times x is how we got the 6x. And finally, 4 times 6 is how we got the 24. And so we would go to write our final answer if we were doing multiplication, where we would write out our area as x squared plus 10x plus 24. So notice that I didn't write it as x squared plus 4x plus 6x plus 24 because we want to remember to combine our like terms. So I have a 4x and a 6x, and when I combine those groups, it gives me the 10 groups of x. So this right here, this x squared plus 10x plus 24, this is in what's called standard form. So standard form always looks like this: x squared plus bx plus c. So every problem that I give you and ask you to factor will actually start out looking like this. And we can think of this as the area of our squares. So of our square. So in this case, you see all of the area was our x squared plus 10x plus 24. And then I can also see in this area model the dimensions. So my dimensions are my length times my width. So I have x plus 6 times x plus 4. And it would have been fine if I wrote x plus 4 first instead of the x plus 6. It doesn't really matter in this case. So you can see my two dimensions here, which give us the area on the inside of the area model. So these are very much related to one another. They're just different ways of writing it. So the dimensions of our square are in what's called factored form. So factored form will always look like this: x plus or minus, and I'm going to say a blank because it will be a number, times, in another set of parentheses, x plus or minus a number. So those two blanks right there, those just represent numbers. Just like in the example above, I had a 6 and a 4 because that's what I saw in the dimensions of my square. So this we can think of as the dimensions of the square. Ooh. Spelled that wrong for a second. Dimensions of our square. Okay, so I'm just going to be referring to those a little bit in the first example. So again, the problems will be given to you in standard form, and you are going to change them to factored form, which is the opposite of what we've done with multiplying, where I would normally give you something in factored form, and you would change it to standard form by multiplying. So we're working backwards again, just like we did with factoring out a GCF. So if I look at this example, factor x squared plus 12x plus 20. I'm going to start off by using my square, my area model. So one thing that we noticed, and I'm actually going to just go back to this slide one more time. One thing that we noticed is when we were doing an exploration in class on this factoring, we always noticed that in these types of problems, the x squared term always ends up in the bottom left-hand corner. The constant term always ends up in the upper right-hand corner. And then my x's, my 4x and my 6x here, they always end up diagonal from one another. And those two pieces, the 4x and the 6x, are really important because the numbers, the 4 and the 6, multiply to give us our constant, but those same numbers have to add, so 4 plus 6, to give us the 10x in our standard form. So if I'm looking at this, I know my x squared is going to go here, and my 20 is going to go here. So I know those two pieces. But what I really have to look out for is this 12x. So some things that we noticed were that 12x has to be broken up in a way that when I add my two numbers, I get 12x. But when I multiply those two numbers, I get 20. So I could think of this, I could start listing some things out. So I know that like 1 times 20 would give me 20. But if I added a 1 and a 20, that would not give me 12. I know that 2 times 10 also gives me 20. And I'm actually going to stop right there, because 2 times 10 gives me my 20. But if I were to add the 2 and the 10, that would give me the 12. So I know what would fill into my box here is a 2x and a 10x, and that would help me find my dimensions. I know that how I get x squared is always an x times an x. And then I think, what would I multiply by x to give me 2x? And that would be a 2. And then what would I multiply by x to give me my 10x? That would be 10. And then lastly, I know that 10 times 2 gives me the 20. So this all works out. And my final answer for factoring is going to be me writing out those dimensions. So I have x plus 2 times x plus 10. So many people find the area model to be really, really helpful. In our next example, I'm going to actually use the diamond method that we talked about in class. Because you guys discovered that, yeah, we could do this area model, but these diamond puzzles that we've been doing are actually this exact same thinking process. So this was my final answer for this one. And now we're going to go to the next one. Factoring x squared plus x minus 12. So it really all comes down to this middle term and this last term. I am looking for two things, two numbers that multiply to give me negative 12, but those same two numbers need to add to give me, and many of us thought, give us x. Well, no, we want to look for the number in front, which, remember, even though we don't see it, it doesn't mean it isn't there. There is a coefficient of 1. So two numbers that multiply to give me negative 12, and those same two numbers add to give me 1. So our diamond puzzle helped us kind of think this through, where we had the two numbers that we were looking for on the side, and when I multiply those two numbers, I'm looking for negative 12, and when I add those two numbers, I'm looking for a positive 1. So you guys can just start plugging in different options and trying. If you're stuck on where to start, I would recommend kind of listing out some different options. So I know that negative 2 times 6 would give me negative 12. And I know negative 12 times 1 or negative 4 times 3. All of these would be different ways that I could multiply two numbers to get negative 12. But I could also say, oh, it could be a positive 2 and a negative 6. So I can change which number that negative is with, because that would also give me a negative 12. Or positive 12 times negative 1 would give me negative 12. Or positive 4 times negative 3 would give me negative 12. Now remember, I know all of these options give me negative 12 when I multiply, but I'm looking for just the one option that gives me a positive 1 when I add. So in this case, I see this is going to be the winning option, a 4 and a negative 3. When I multiply those, it gives me negative 12, and if I were to add 4 and negative 3, that gives me positive 1. So my final answer would be x plus 4 times, in parentheses, x minus 3. So I have now changed that from standard form to our factored form. And let's just do one last example. So I have x squared minus 15x plus 56. Again, if you like the area model, use it. I'm going to use the diamond puzzle. Oops, what am I doing? Subtraction and addition. Multiplication and addition. So I'm looking in this example for two numbers that multiply to give me positive 56 and then add to give me negative 15. So two numbers that add to give me negative 15. So what I notice is that when I add these two numbers, I get a negative, but when I'm multiplying these two numbers, I get a positive. The only way for that to happen is if the two numbers are both negative. So I would look through my options and think like, oh, negative 1 times negative 56 would give me a positive 56, and I can go through all of those options. What's kind of hard for us to accept about these types of problems are that they do get easier the more problems you practice. So if you're feeling like you're struggling a little bit to start out with, that's fine. The more that you see these problems, the more they're going to become much faster for you. So I would notice that I could multiply negative 8 and negative 7 to get a positive 56. And when I add those two numbers, it gives me a negative 15. So my final answer would be x minus 8 times x minus 7. Okay, so there was your recap on factoring x squared plus bx plus c.